Yeah, awesome. So welcome everybody. Today we're gonna be kind of transitioning from the previous month. In the previous months, we kind of started you guys with what are kegel competitions, and each one of you did some EDA and kind of get a feeling for starting a kegel competition and what they are. And today we're going to be for the this month and then also for the remainder of the semester, we're going to be transitioning a little bit to actually participating in competitions. And today is going to be mainly on a clay overview. And then also I'm going to be talking about what we're going to be doing for our competition for the remainder of the semester, because I do have some news to share about that as well. So today is going to be like very laid back and just a very open talk about my experience just attending and going to Clay. And I believe Ritesh is also going to be talking about a little bit of his experience of participating in Clay and a little bit of the research that he did. And I'm also going to be talking about the for Clay next year. So yeah, so this is going to be the overview. So we're going to be talking about the labs, just a quick overview of all of them. And I'm going to be talking briefly about the keynote speaker. I'm going to be talking about some of the labs, the conference sessions, some of my thoughts, and then later the team formation, how you guys can start thinking about that, and solution sketches maybe. And then yeah, what's next? So yeah, a few weeks ago, I got uh, the privilege, I guess, or yeah, just a really cool experience of going to Grenoble, France. It's in the Alps, so it's very close to Switzerland in France. And he was in the picture here on the left. On the left is Misha Shank and Anthony and Terry. So we all went to Clay and we participated in the conference. The conference went from Monday through Thursday. So it was a 4-day conference. We had morning sessions and evening sessions. And then here's just some of the pictures. So this is us on the left, and then here is Anthony presenting or basically everything that we did for all of the labs. And then Shashank is on the right here presenting right here. So yeah, I kind of put together a lot of the pictures that I took throughout the trip because Grenoble is really nice. And the Olympic Games of 1968, the Winter Olympic Games were there. So they still have, there's like this little cart that goes through a line that goes all the way to the top of, I guess, a fortress on top of a mountain that overlooks the entire city. And there's also a river that crosses the city. And the city is quite big. I think there's like 700,000 people in the city, and the university is really big. And it's beautiful because in the university, you can overlook all of those Alps. And yeah, it's just a really beautiful place. So like here's a picture of the campus at the university, so you can see all of the Alps surrounding the university. And then after the conference, me and Anthony, we got to travel just a little bit. So we went to the city called Annecy, which is in the north of France, kind of heading towards Switzerland. So it's a city, they call it the Venice of France because there's canals that go through the city and the water is super clean and it's beautiful. I've never even heard about this place and it was honestly amazing. Like probably the most beautiful place I've been in my life. So yeah, this is another picture of the city. Is also surrounded by Alps and it's just so beautiful. The water is really clear and they also have like a big castle over there. So yeah, this is the picture that I took at the sunset. And then this is like a little fortress that is very famous that is inside the castle, the canal, and it's kind of what it looks at night. And then later, Anthony and we also ended up going to Switzerland for a day, and I ended up walking like 12 miles that day, I think. I walked a lot, but it was really, really cool to see Geneva, this Geneva. So we went all the way to the top of a cathedral that had a really nice view of the entire city. And it was just a really cool place to go. So yeah, this is the clock tower, the flower clock. a very famous garden in Geneva. And then this is just a picture of the sunset, which was really pretty because it's also surrounded by mountains. So when the sun sets, there's this color of orange that I've never seen in my life for a sunset, which was quite incredible. So it was really cool, like going to a research conference and presenting your findings, but also having a great excuse to travel to Europe. For me, it's a win-win situation for sure. Okay, so yeah, last week I told you guys about just going to the website CLEF and kind of um, finding what would be interesting. So what is CLEF? CLEF, it stands for Conference of Labs and Evaluation for. So it's a conference and it has many different labs. I believe next year is going to be a total of 15 labs or something like that. And each lab has their own tasks that is specific for that lab. So each lab is trying to solve a different problem. And then you have different tasks, which you can think of them as like different flavors for solving that problem. So yeah, so in alphabetical order, all of those are the labs. So we have BioAsk. I, I forgot to change the 2023 here, but it's supposed to be, I believe, the 2024 link. So it's for biomedical semantic indexing. We have check that is checking worthiness of natural language. We have e-risk prediction of e-risk in the internet. So I believe if it's related to things like depression and things like that, so you can kind of predict those things in people's sentences in the internet. We have exist, identification of social networks, IDPP, which was the one that Ritesh participated, and Shashank presented their work. We have
Yeah,
image
by
play.
the way, this lab is not offered anymore, so just FYI.
Yeah, this,
Yeah,
yeah,
this
exactly.
was the last
So
one last year. So 2025, I was looking at the list. There are 14 labs uh, offered in 2025. But yeah, this is not one of them anymore.
exactly, yes. So IDPP, it was the last time that they had they were part of play, and this happens like naturally, which I didn't know. The labs usually have a lifespan of about 3 years, 3 to 5 years, depending on the lab. Some labs have been running for decades, like I think life play has been going, or image play has been going almost since the beginning of clay. But usually labs, they start and then they have a lifespan of 3 to 5 years depending on the lab, and then they close down and then they open new ones, which I'm going to be talking about. So we're actually going to have new labs, or a new lab for next year's conference. So we also have image clay, is multimedia retrieval, mainly images, but also multimodal stuff. So like image to text challenges. And then we have Joker. It's automatic autoplay of analysis. So it kind of focuses on the wordplay and interpretation of humor. It's actually kind of funny. They also do things with memes. It's kind of cool. So Live Play, this is the one that, and Live Play is the one that he started everything because it's the one that board play is in. So Life Clay, all the labs in Life Clay are, I'm going to be talking about that later, but basically Life Clay is about multimedia retrieval in nature. So biodiversity, species identification, that kind of stuff. Longeval, longitudinal evaluation of model performance. So it's about temporal persistence of IR systems. We have PAN, digital text for forensics and stylometry, focusing on digital text forensics. And then we have QClay. QClay was introduced in 2024. It's brand new, and I know a lot of you guys are super interested in participating in that. So it's really about quantum computing algorithms, and more specifically quantum annealing, which is going to be really cool. And they're going to have, I believe, 2 tasks next year. We also have simple text. It's basically address text simplification for scientific information, and then to shape computational argumentation and causality. So most of those tasks, most of the labs guys, they're really about NLP and computer vision. Um, yeah, and some of them also address like multimodal things, and some of them are switching to more multimodal tasks. So basically, how do the conference looks like? So this is the first day. It's as you can see, there were many different rooms that you can go and attend to, and only room one was in this amphitheater, and rooms 2 to 5 were like literally on another building, and each room is happening something, or each room is happening a lab at the same time simultaneously. So there's no way to attend all of them. You kind of have to pick whatever you wanna see. So it started with registration on the first day, and then there were some opening notes, and then there was a keynote speaker, which I'm gonna be providing a very quick overview of that. And yeah, we met at the conference session, and then we had a coffee break. The coffee breaks were nice. It was a great way to just talk to people and just talk about the research. Sometimes even 15 minutes of people explaining their solutions were not enough. So basically, on those conferences, each talk was 15 minutes long, and it was basically just people presenting their papers and their solutions. And then the first day was also when live play happened, and Anthony presented live play literally the last session of the day. But it was really cool, and it was really cool also to meet all of the organizers, and also to meet the organizers for the other tasks. So for day two, we had image clay, simple taxi, risk, bioask, and pan. And then for the early sessions and then the afternoon sessions, they changed a little bit. Check that presented. Image clay is one of the big ones, as you will see. So some of them, they happen in like 4 different sessions, like image clay. Simple tax had 3 sessions, and so on. Bioask also had 4. So some of the labs, they're bigger than others, which is okay. Which, by the way, Life Clay started with dead image clay, but then it became so big that it became its own lab, which is pretty cool. And then on the third day, there were those labs that presented. Again, same kind of format. There was a keynote speaker, conference session, coffee break, and then we got to go and check. So QClay happened on the third day of the conference. And oh, maybe I forgot something. On the first day, sorry, we had a reception at La Bastille. So this is the place that I showed in the very first photo, that fortress kind of place that overlooked the entire city. We actually ended up having dinner all the way there with everybody in the conference. So they basically closed down the fortress just for us to have dinner, which was a really cool experience. And then on the third day, we ended up having a gala dinner inside the Grenoble Museum, which was really cool. Anthony and I also got to do some touristic things of just walking around the museum before the conference started, and they have some really famous paintings from Monet, and some really other impressionist French artists in the Grenoble Museum, which was quite really cool to just go and see. And then the fourth day, yeah, those were again the conference sessions, coffee break, and then usually at the end of the conference, the last session that they have, the closing session, it's when they announce all of the changes that I'm gonna be presenting to you guys today. So kind of like what you should be expecting for the 2025 conference. So yeah, so the conference opened with this with the keynote speaker, which was Paula Carvalho. She's from Portugal, and she was really talking about hate speech and trying to understand hate speech. So basically, I'm not gonna go too in depth into that, but it's basically there's no definition of what it is. Hate speech is very nuanced, which I thought you'd be. I thought it was surprising because it's such. If you think about hate speech, it's such clear like what it is, but it has so much nuance into it because it goes into culture and a bunch of other things. So yeah, like I said, it's kind of like a continuum. It's really hard to categorize into different buckets. Let's say like this is more hateful than that. But yeah, it's a research. I thought it was really interesting. And then if you guys click here, the no hate, it's basically a campaign that they're developing against hate speech, which is really cool. And then this is kind of what they're doing. So they have 50,000 annotated comments from, I believe he was YouTube and Twitter. Yeah, right here. And they're just creating models to identify hate speech and basically levels of hate speech. So they have a bunch of different criteria for measuring that. And I thought it was very interesting. Again, just continuing from that, I'm not going to go too in depth, but you can kind of check the notes and you can check what they're doing. And yeah, I thought it was a really cool presentation on hate speech. So yeah, so Life Clay, like I said, the clay has many different labs. I believe it's next year is going to be about 15, and Life Clay is one of them. And Life Clay is all about biodiversity conservation. So it's multimedia, which means different sources of media. So we have images, but we also have audio mainly. So yeah, images and audio. So plant clay is about identifying plant species in images. So we have a really big data set. This year it was 1.4 million images, about 300 gigabytes of data, and we had 7,000 different plant species. And you gotta identify or classify plant species in images. And it was really challenging because our training data was single label and the test data was multi-label. So bridging that gap was quite hard. And some people came up with really clever solutions that I'm looking forward to trying next year. GeoLife Clay was also an image task, very similar to Plant Clay, but it was more like satellite images. And Anthony was the one that was leading that task. Board Clay is about identifying board calls in audio, and it's probably the most famous one because he runs on Kaggle, and he has a really big cash prize. So he's the one that has the most amount of people participating, and they do in partnership with, I believe it's sponsored by Google and Cornell Ornithology Department, which is a really big department in ornithology, just studying birds, and it's a very popular Kaggle competition. Again, because of the cash prize, it attracts a lot of people participating. Fungi clay is about also identify fungi in images. But not only that, it's supposed to identify the not benign malignant, but like the edible and venomous fungi species in images because they're very similar to one another, and it's really hard to distinguish between them. And snake clay again is also very similar to fungi clay. It's about identifying snake species in images and also from venomous to non-venomous snakes. And oh yeah, so Ritash, if you'd like, this is about your paper. If you'd like to kind of just talk through what you guys did and maybe explain your solution.
Yeah, thanks, Marilla. So my last Clay 2024, me, Shashank, and Alex, we were the three folks who took participation in the IDPP, which is Intelligent Disease Prediction Progression. So we basically have to predict the progression of a particular disease. So in this case, it was a flavor of a disease, multiple sclerosis. I think some folks might know about it. So one of the flavors of multiple sclerosis is called ALS. It is amyotrophic lateral sclerosis, which the name comes in the slide, ALS. And then FRS-R is essentially a score given to every ALS patient, and that score is essentially tracked over every month or in periodic fashion to see how the score is progressing. The score going down, meaning the patient is getting more sick, and it's basically atrophying in general. It's a deadly disease because it most of the patients who fall into the disease don't live more longer than 4 to 5 years. Uh, but predicting the score does help into diagnosis and also helps into finding cure, or at least something that would help. There is no cure at this point, but you can at least manage the symptoms and make your life a little bit better because it affects a lot of different limbs, spinal cord, nervous system, a lot of different places it affects. It makes the patient's life essentially very miserable. Uh, so so we took up this challenge. One of the biggest challenge in this one that we had was the data set. Usually all the labs had a data set massive amount of data set. The handling data set was a problem, but in our case, it was the other problem. We had a very small data set. We had only 50 patients data. And it was a longitudinal data set. It wasn't like a two-dimensional data set. It was a three-dimensional data set, right? For every patient, we had time series data. For another patient, we had time series data, and so on and so forth. So we basically had to somehow summarize the data into kind of one line and use that for prediction. Uh, so our task was we were given the score uh, until, like, for example, 18 months, and we were supposed to predict what the score is going to be on in 21st month. And we were given sensor data also. Sensor data, well, these are the data that is patient is getting tracked on with the mobile app, like how many steps the patient is walking, what is his heart rate, breathing, uh, and other baseline information like age, gender, and some of their vocal capacities and stuff like that. So we were giving all this information, and we were given the score on the last visit to the doctor. Now we are supposed to predict what is going to be in the next visit of the doctor. So that was the whole task that we had. And on the screen that you guys are seeing is the score is essentially a sum of 12 questions, and that's what you see on the score in the little box, that there are 12 questions in there. So whatever patient gets for each and every question is added up together, and then that's your score. And every question can go from 0 to a 4 score. So the max you can get is 48, and 48 means you are perfectly fine. I mean, you have no problem at that point, and 0 means you pretty much are no more. And as you can see, from visit to visit, the general trend in that box is downwards, right? Which kind of makes sense because the score is essentially going to go down over a period of some time. So we tried multiple models here to kind of predict this thing. Our baseline model was just use the previous score as is without changing anything, right? That was one of our baseline models, right? So that we know that this is our baseline. Now we have to work off it. Everything has to get better from here point onwards. We tried deep learning models like LSTM. We did classical machine learning models like the one that actually won us. So we won the competition. We were one of the first ones to win the competition here. And our model that actually showed good performance was ElasticNet. That's what we ended up having. So a combination of ElasticNet and some other machine models collectively gave us a very good score. But the interesting part was it wasn't better than the baseline score or just using the last score. For whatever reason, the amount of patients that we had, the data that we had was not enough for showing some kind of progression. So that's what it was. So yeah, we submitted the models. We won the competition. We ended up writing a paper on it, and we have a paper published out there in the conference and also on archive. So it was a good competition. Different challenge. Smaller data set brings in a lot of challenge, and patient data in general has a lot of challenge because every patient is his own trajectory, right? In images, it is very, I want to say linear, but at least you have some understanding. There is no heterogeneity, right? In images or other stuff, but in patients, every patient has its own way of going up or down the scale, and you have to kind of really capture everything in one model is extremely difficult, is what I learned. Maybe you have to create clusters of patients and then have model for each one of them. That was another thing that we wanted to try, but yeah, the lab is no more there, so we can give it a shot. But yeah, that's all I wanted to tell. I think if anyone interested, yeah, just ping me and I can give more information. Our paper is out there. You can even read that paper. So yeah, thank you. Thanks, Murula.
Yeah, thank you very much, Ritesh. And it was really nice to go and watch Shashank present
Yeah,
your paper. It was just really cool. And also just hearing from the organizer as well, just how difficult it was to just gather the information over the years, right? Because from a follow-up to follow-up, a lot of people ended up not,
not showing up.
yeah, they
Yes.
don't follow through. So that was very difficult to gather the data for this competition in particular. But
Very interesting
somebody,
data set, yeah. Because a lot of patients would have like one or two visits and then that's it, dead. No visits after that. A lot of patients would have a lot of visits, but then very irregular times. So it was, for the lack of better word, it was a complete mess when you see the data, right? And you have to kind of make sense out of it, kind of arrange it in a proper fashion. And I think the patient data is also very less because the good reason, one of the good reasons, there are very few patients out there in the world that get this disease. It's only like 4 or 5% of the population
Hmm.
that get this disease, which is good. But that's also the reason why there's not much data. So there's not much research. So there is no cure, right? I mean, it all kind of falls back to the same thing, right? But yeah, it was interesting though.
Yeah, but it also, I think, undermines of what Clay is about, just trying to solve real
Difficult problems, yeah.
problems. Yeah, for sure. Very applied stuff.
Right, very applied stuff.
Yeah,
Yeah, that's what I learned. Very applied stuff. Agree. Yeah.
for sure.
Thanks.
Cool, awesome. Yeah, so here are my overall thoughts of my experience just going to the conference for the first time. So it was my very first academic conference, and I definitely had way too much coffee from the sessions, just trying to be awake. 6 hour difference of time zones. So in the beginning it was quite hard, but the food was great. I mean, it was in France, so you can expect the food to be great. So yeah, I asked a lot of questions. Anthony was asking a lot of questions, which I thought he was really, really interesting. If you ever go to a conference, don't be afraid of asking questions, because something that you think would be or sound not stupid, but sound simple to you, it might be a question that other people may have. And Anthony actually got a lot of compliments from people just from asking questions, like in between the sessions. So it was something that yeah, just ask questions. It's really good. Also, I got to meet a lot of people from many different places. So American guys, Germans, Italians, Portuguese, Spanish, Taiwanese, both professionals, but also professors and undergrads and masters. A bunch of PhD students as well that just went to the conference. I mean, a bunch of them are in Europe. Even some PhD guys from Switzerland, yeah, kind of all over. But it was really, really cool experience to talk to them and see what they're doing, see the difference of the infrastructure and the supports that they get on their country versus the US. Definitely a lot of differences, especially compete wise, which I can, if you, yeah, like, I guess I can talk about that a little bit. So, for example, in France, they do have a super cluster, or like a huge cluster that is dedicated for the entire country. So, if you work in academia or you're doing research, you can literally just put your stuff on a sign up sheet, and then you get access to this huge cluster for compute, and it's completely free. So, for example, the organizer for Planet Clay, he told me that he had access to 12 nodes. Each node had 8 A100 GPUs that he was using, and that was completely free for him to use, which, like, in the US, it's unimaginable. That was something that I learned from other people going to the conference and presenting. Like, all of the PhD students from Germany or France or Switzerland, they had access to so much resources for training, and our solutions were basically resource constrained. So we had to kind of be creative in what we're gonna be doing. And also, some of the labs, they're trying to enforce their solutions to be more constrained in the terms of the resources that people use. So, for example, Berkeley has a cutouts of 2 hours for the inference time. And that's because they don't want people to just be creating bigger and larger models, because of course you're going to have better performance that way. But it's not like Ritesh was saying, the conference is very applicable to real life world problems. So you don't want to have those huge models taking this huge amount of time to do inference if people are not going to be able to use them and put them to actual use, which, by the way, those things are actually being used by, like, people in real life. So you are contributing towards something that is very tangible, which is really cool. And yeah, making a submission is totally doable. I think that, like, going from just having one team from last year to having like 11 papers published, I think it definitely shows that it's super doable. Yeah, gotta really thank Anthony for starting all of this, but also like everybody that participated did a wonderful job. No matter how much they contributed, it's kind of a situation that you get what you put in. You get out of this situation what you put in. So the more that you dedicate yourself and the more that you want to dive into that, I think it's going to be more and more rewarding. But it's super doable to do a paper. Like it's a very beginner friendly conference to participate. I actually think it's like the perfect conference, like a first conference to go to because it's very easy, low barrier to entry. So if you're interested in doing research and publishing a paper while at OMSS or just at Georgia Tech in general, I would highly recommend you guys try to join our group in the spring. So yeah, so Clay 2025, let's talk about what the future holds for us. So as you can see, this is Madrid, which spoils a little bit, but Clay 2025 is going to be in Madrid, Spain. So I'm definitely going to try to go again. I've never been to Madrid, but I hear amazing things about it. So it's also a good excuse to travel, I guess. If you like traveling, you can do both. You can go to the conference and you can travel a little bit like I did. So yeah, Clay 2025 is gonna be Madrid. So here's I guess the biggest changes that we're gonna be seeing for next year. So Board Clay, they gonna announce Board Clay Plus. They haven't decided the name yet, but I think that's what they're gonna call it. So it's not only gonna be on board species anymore, but also insects and amphibians. So because when they put the sensors out in the wild to capture bird calls, they also ended up capturing insects and amphibians, but it's in a higher bandwidth of the spectrum of the signal of the not voice but the sound. So birds they operate in a band of hertz, and insects and amphibians operate in a higher band, and they're gonna include the higher band in the competition as well. So we're gonna be able to identify insects and amphibians as well. So they're basically expanding that to a bigger, harder problem. And Animal Clay is going to be on the task on identifying and tracking wild animals. So basically, when you see a wild animal, they want to track not only the species, like the species that the animal is, but like literally that specific animal. So, for example, if you think about whales, it's you know how people can track them by the shape of their tail or like the dots that they have, depending if it's I forgot the name of the whale, but some whales they are covering dots, and you can by just taking a picture, you can track which whale is because it's kind of their digital fingerprints in a way. So they're gonna be opening this task on identify some kind of animal, and it's gonna be I believe it's gonna be specific to one animal, and we don't know which animal is gonna be yet. But they're opening this new task under Life Play, which I'm very much looking forward to since I like computer vision so much. Also, Talent Clay, this is a complete new lab, and it's about information retrieval for job postings and career skill building. So I think it's focused on like LinkedIn posts, and they're gonna have I think two tasks under the lab. One is gonna be on job title matching, and the other one is gonna be on job title based skill matching. So one is more like the job title, and the other one is more about the skills of the job. So kind of cool lab that they're opening. So Exist is moving from NLP towards more multimodal problems. So this is the one that they also had the meme kind of task where they give you a meme and you have to basically provide the meaning of the meme, which is not, I mean, for us, it's super easy to know because like memes for us are very second nature. Like we look at them and we understand them, but for computers to understand the nuances of memes and the sarcasm of them, it's a difficult task. So they're kind of trying to go all on or full on the multimodal route. And Touche is also moving towards RAG systems. So if you like RAG and you are interested in doing RAG, I'd highly recommend checking out Touche. It's a really cool lab. And I guess just the infrastructure and tools that we're going to be using for next year. So not all of this is not set yet, but it's basically what we did last year and what you should expect for us to be doing again. So again, we're going to be using GitHub for all of the labs that we're going to be participating. Um, we basically do all our dev work on GitHub for just tracking also all of the infrastructure and setting up the cloud resources are going to be, we have a lot of documentation there. And yeah, just it's a good way to keep our code, um, yeah, in a good format. So yeah, we're going to also be using VMs on the cloud. So we usually go with Google Cloud, not only for the VMs, but also for the storage of our data sets. So basically how that works, we have a VM on the cloud. We teach you how to SSH into the VM, and then you do all of your work in the VM, and that's through VS Code. You can use other code editor, but we highly recommend using VS Code. And then we also use some buckets in the cloud to store all of our data and pull the data while we're doing the competition. And then we're also going to be doing stuff with Python, PyTorch, PySpark. PySpark is for distributed data loading and also parallel computing. So really cool, makes things much faster when you're dealing with a lot of data. And Luigi is for orchestration of tasks. So basically, you can run Luigi tasks, and usually the models take a while to run, so you can keep track of them while they're running without having to worry about. And you can kind of see like the progression of your model during training. And so, yeah, very cool technology. So yeah, so team formation, just talking a little bit about that because that was something that I asked you guys to do. Just go on the website and then check what would like to be or what you are most interested about. So if you have not done yet, so please do by the next time that we're gonna meet next week. So go on the working notes. Again, if you go on this website, again, if you don't know how to go, you just type like Clay 2024 working notes, and it's probably going to be the first one. So this one. And each single, let me make this a little bigger for you guys. So each single lab, the very first paper of each single lab is going to be the overview of the lab. So we have BioAsk here. So for example, BioAsk, this is the overview of BioAsk. So it's literally, it looks like a paper, but it's basically, this is made by the organizers and it's just what the lab is about. So it's literally a paper just explaining what BioAsk is about. So every first paper for every single lab is in-depth overview of what the lab is. And then everything else is all of the tasks that people submitted, the working notes. So this one, again, overview of e-risk, overview of exists, overview of IDPP. IDDP is not going to be anymore, but here's the overview of that, image play, and so on. So yeah, choose a lab. I would say that if you are serious in participating, it's going to take about 50 to 100 hours total throughout the semester. You can definitely go more. I think that I ended up spending way above 300 hours, probably around 400 hours for what I did. But I also was doing that for my class, which I'm going to be talking about later, which is oh, also find when the lab opens and then also read the previous year's paper. So this is a really good way of knowing what people have done in the past and what works. For example, I'll just give an example which people probably don't know is that bird play, it's identifying bird species in audio, but it's actually a vision task which you're like, wait, what are you talking about? Basically, the people that win wordplay, they convert the audio into spectrograms, which is basically the images of the audios, and they train convolutional neural networks or just vision networks in the spectrograms of the audio. So they're training CNNs on the images of the audio, and that works really, really well. And the people that ended up winning board play, they do a bunch of stuff with pseudo labels and unsupervised learning that works really well. But yeah, they're basically training CNNs or just vision, not even vision transformers like efficient nets and other models on images of the spectrograms. So yeah, so this is stuff that you learn by reading the papers that were published on the previous years. So we ended up learning a lot about how to approach the problems. Highly recommend. Also, if you're like super serious about just going all in into the research routes, consider doing CS A903. It's called Special Problems. It's what I did in the spring. And I attach here, I will be sharing the slides. If you don't have them, I'll share them after the meeting today. But this here right here, so if you click here, it's basically my statement of research that I did for CS A903. So basically how it works, you have to write a research proposal and you got to have a professor to basically, it's not sponsor you, it's, how do you say that?
It's more like an advisor.
Yeah,
Yeah,
advise you. Yeah,
it's an
thank you.
advisor. It doesn't have it. Yeah, I mean, he doesn't have to know anything about the competition overall. I mean,
Yeah.
he's just there. I mean, for the lack of better words, he's just there to sign at the end that, hey, yeah, this guy did the research. He has some paper, and then he gets A, B, or C, whatever grade. Right? That's pretty much the job.
Yeah, exactly. I think the word that I was trying to say was supervise. So you get as a professor to supervise you. I got Dr. Kira from deep learning. I can talk later about that if you're interested about doing this, how I got a professor to supervise me, which is something that is not as easy as people may think. But if you're thinking about doing that, I would highly suggest for you to start thinking about that early. So, you just have more time to prepare for asking professors and things like that. So yeah, you can see what I did for my statement of research. So, yeah, all of this is available for you if you like to kind of take and apply for the A903. Please feel free to reference this. And then, oops. So yeah, so the next thing is also gonna be we're gonna be doing some recruiting and joining teams. So teams are gonna be from 2 to 5 people. We really like teams of 3 people. I think that's really the sweet spot of the size of teams. And yeah, and we're gonna actually try. The main goal is gonna be to try to participate in every single lab that we're gonna have for next year. So all of the labs that I showed you guys, including the new ones, we're gonna try to have one team for every single lab. Um, and yeah, hopefully teams of 3 people would be nice. So yeah, 3 to 5 people each. And so every single lab, 15 labs, teams of 3 people, 45 people, but also there's going to be multiple tasks within each lab. So we might have to expand even above like 45 people. So we might have to end up doing some recruiting because we're not going to have enough people for all of them, perhaps. We don't know yet. I'm just saying. But yeah, this is kind of what you should expect. Um, before I do questions, I think I'm gonna come back to that later. Or maybe we do like questions for 3 minutes, and then I really wanna talk to you guys about the what we're gonna be doing next, which is this. I'll be sharing this after the meeting if you don't have access to, but this is gonna be the competition which starts today.
Yeah,
um,
we have a link in the working notes anyway. So even if you miss talking about it, the working note,
okay.
the document is very elaborate. Thanks to Anthony, everything
Yeah,
is in
yeah.
there. Yeah.
Yeah, like all the information is gonna be here. I'm gonna be kind of going over that right now, but let's just take questions. Yeah, just any questions that you guys have. Let's do like 3 minutes of questions, and then I can stay after if you have questions and they were not addressed. I can stay after the meeting. But any questions about Clay and or experience in general about Clay?
I think there are some questions regarding uh, team formations and when to start the research. I think team formations, I think Marilo already mentioned in one of the slides. We expect 2 to 3 people in a team. One person, I don't think having gone through it can handle the entire competition or even a task. I mean, it would be a lot of work, especially if you're not getting any credit for it with like 8903 or 8901 or 8902. By the way, 8903 is not the only one. 8903 3 means 3 credit hours, but you can also do 8902, which is 2 credit hours, or 8901, which is 1 credit hour. I did 8901 last semester when I did CLE, but I think it is more like a 8902. It is more like a 2 credit hour work rather than one. But yeah, keep in mind that it is a lot of work. Even with three folks in a team, it is a lot of work with whatever course you might be taking in that semester, right? And then if you, and this is only the competition, right? And then if you end up getting selected or want to write working notes paper, and that's going to be another amount of work which you have to spend time on, right? So as far as doing the research, the competitions usually open up November, December, right, Marilo? I think November, December
Uh,
timeframe. They don't have set
it
time.
it really depends the lab. So
Yeah,
each
it really
has
depends on
their
that.
own time frame. For
Right.
example, even within live play, each task ended up opening at different times. So board play ended up opening in January, but playing play they only had a date available by the end of February. So it
Same
really
here, yeah, for
depends.
IDPP also.
Yeah, so it really depends on each lab, but we like to start as soon as possible in January because there's just so much setup and infrastructure that needs to be done. I mean, there is like a real learning curve for just getting up to speed with the tools that we use. So if you're not familiar with them, we really like the first couple weeks we try to teach you how to use those things. I mean, we record sessions, we have sessions about that. But yeah, yeah, the each competition has their only kind of timeline.
Yeah, I
Uh,
think the point being, every what I have seen is that every competition or every lab, it at least gets March, April, at least gets 2 months minimum for their entire work, right? For example, IDPP, the data set was released somewhere end of February, and the competition submissions were end of April. So we did get 2 months. So every competition gets at least 2 months or more. 2 to 3.5 months is about the time frame that you will have. Uh, yeah. So keep that in mind. I think what Marilo is also mentioning is beforehand there is a lot of research to do. Once you choose a lab, you will want to read the working notes paper from past years. You will want to do your own research and find out own research papers online on archive or wherever to see what solutions you can apply and come up with a plan, right? The work will not start when the lab just opens up. Work will start well before that, right? Because you want to prepare yourself, because most of us would not know much of the information other than the lab and just the overview of it, right? So digging deep will take some time, and Google Cloud, getting familiar with, has its own timeline to learn for. So there will be things to learn, a lot of it, before the competition starts.
For sure. Yeah, and we'll help along the way. But yeah, there's
Yeah,
just so
of
much
course.
setup and getting up to speed. So kind of having an idea of what you're going to be doing and kind of the overall solution definitely helps. And the sooner that you can get up and running and like literally trying to train a model as fast as you can, it's really kind of one thing that I'm going to be trying to do next semester. And it was something that I underestimated how much time it takes to do that for the previous semester. But yeah. Okay, so last question I want to address before I move on, and then if you have more questions, feel free to stay after the meeting. But does he like how you can register for the A903 if you're undergrad? I actually have no idea about that. But okay, someone commented there's an undergrad course equivalent
Yeah,
to
4903.
4903.
Yeah.
Okay, yeah, cool. So good to know.